Hi everyone, and thank you for having a look at the pictorial named Smörgåsbords for physical computing. My name is Boer, and this work is done together with Harvey Bewley at the IXD lab of the IT University of Copenhagen. This work is mainly motivated by us teaching interaction design projects that involve physical computing, and in particularly teaching those students who are new to physical computing. And when we engage students with physical computing, we show different materials and we combine them as well. And it's from left to right here. We have composed electronic kits that we hand out to students. We show the drawer store units that contain all available components. We hand out books for self-study. And we show what actually can be produced with physical computing by showing them prototypes or showing them online prototypes. And this can be very successful because combined they provide an awareness of components that are available in-house, an awareness of their physical appearance. They stimulate hands-on or step-by-step learning, and they illustrate the potential of physical computing. However, we felt that something was missing in this collection. And in particular because we often saw that these materials can be experienced as overwhelming or intimidating, but moreover, that none of these provide an immediate experience of what an individual physical computing component can do to newcomers. To start this process, we first looked at the offerings that we actually have available in-house. And we looked at all the sensors and actuators in particularly. These are the most frequently used sensors and actuators that we also lend out most often. And by organizing these on a table, we actually saw these different categories emerging. For example, sensors could be clustered into movement, environment, flex and force, distance sensors, passives, and switches, while actuators could be clustered into ones that dealt with tactition, audition, thermoception, or vision. Doing this activity reminded us of a Swedish Smörgåsbord. And that is a collection of celebratory dishes of various foods served buffet style on a table, where guests serve themselves from the possibilities laid out for their choice. And inspired by all these different offerings, these varieties of possibilities that can be physically explored and experienced independently, we initiated the boards or kind of electronic versions of these Smörgåsbords to display a collection of physical computing components. And we initially thought of one board that would offer a buffet of sensors that could be explored, and another one would offer a buffet of actuators that could be explored. And our students could then approach these boards, play with each, get a tasting of each, and see what one actually does. So our ideas is illustrated on the right image here, where you see these different clusterings from the previous image, this projected onto a board. And to continue our form-giving process, we articulated 4 design principles. The first one was to aim to demystify the function, form, and feel of a component, to instantly experience its basic form factors. Secondly, we wanted to facilitate very simple interactions to quickly and playfully explore the potential for interaction of these components. Third, we wanted to group, label, and stage the components in a categorized way to allow students to compare them, but also to give prominence to their form factors. And fourth, we wanted to use only those components that we actually have available so students can have access to them and can start working with them right away, and also get the support for them that is needed. So this resulted in a very first board, which was the sensor board. And what you see here is grouped individual components and staged in a kind of meaningful way. And what you can do, each component had an LED hidden underneath it, and you can use the clickable scroll wheel in the bottom right to select one of the sensors. And upon selection, you can then manipulate the sensors and the output would be displayed on the screen. So this clickable wheel the click could select the output mode. So on the one hand, you could have a numerical value, and on the other hand, you could have a horizontal bar graph. And this movie shows how the selection of the sensors would actually take place. Well, this movie shows how the numerical value is displayed. The second board that we made was the Actuator Board. This followed very similar principles, although here we didn't use a scrollable click wheel to select the actuator, but we wanted to have interaction happening with the actuator directly itself. You can still see a rough grouping here. On the left, there's mainly motors, DC motor, servo motor, stepper motor, vibration motor, and a fan. And you will see towards the right are more vision-oriented actuators, the 7-segment display, LCD display, or RGB LED. Here's a movie that shows the interaction with the board. We start with the shape memory ally that can be activated by a simple button press. Then an LCD display with buttons to activate its output. A 7-segment display that shows a number. An RGB LED, where each leg of the RGB could be manipulated individually with a potentiometer. A fan, a solenoid, an air pump, a vibration motor, each activated with a simple button press. Here, this piezo buzzer could also change in its sound it's produced. The stepper motor could be changed in the angles that it set, and the servo motor similarly. The DC motor, again, with a simple button press. And then you could see how quickly you could actually, in brief interactions, like little tastings of these components, get a feel for what each component can do, and they give a good impression of how each component works and can function. This inspired the development of 2 other boards. So this one zoomed in on one component and actually showed the potential that lies within one component when it is embedded into different materials. And the resulting interactions are thus also very different. So here you can see silicon hair, silicon, spring, fur, and a water balloon. And we combined this with a simple LED output to show how interactions like here, tickling these silicon hairs, what they could trigger. Touching silicon or squeezing. Activating a spring. Stroking or going gently through fur. And actually to push the boundaries a bit to also show that it could be embedded in a water balloon and that the squeeze could be detected then. A last board that we made was exclusively focused on the light sources we had available in the lab. You can see from left to right an incandescent light bulb, a single colored LED, an RGB LED, a neopixel LED strip, and an LED matrix. And you can see a control in the bottom right that enables you to set different temporal form possibilities. For example, the light bulb, when the horizontal position would change its blinking speed, and the vertical position would change its intensity. And similarly for the neopixel strip, the horizontal position would change the color from red to green to blue, while the vertical position would set its position on the strip. This video shows the mechanism behind the controls, 2 simple potentiometers. And here on the left, you can see the outputs that the light board gives when the control unit is set to the top left. As a collection, we staged these boards permanently in the main corridor of our university building, and this had very positive effects on very different levels. They gave visibility to the practice of physical computing. They triggered very playful interactions with physical computing components. They raised curiosity and excitement in doing so. And overall, they invited and inspired students to think in possibilities beyond the screen. Practically, these boards also helped a lot in realistically constraining student projects, as they were better informed about the limitations and possibilities of some components, and students had better expectations of what actually could be supported when they would start with their projects. Thank you.